Okay. Excuse me. This is the demonstration for the performance testing assignment for C# 2. So, form opens form performance test. It's the only form I have for this. For the code, it is pretty straightforward. The button click pretty much handles everything. It all goes through this one button click, runs the whole program. The initial part here, we gather the string from the text box input that's on the design form here, which has the label for given directions as to what to do, an entry text box, a button, and then two labels that also display output for the performance of the sorting and the building of the array. And then I've got two progress bars that just show a comparison of time as to which one took longer and by somewhat of a ratio. And so here we get the string from the text box. We then check, so here we're checking if it's a valid integer. So we do a try parse on the input, and then we send out that value. As long as it is an integer, it will send out that value as long as it's an integer and it falls between 0 and 10,000. I guess that would be, we don't need that one then. But yeah, greater than 0 and then less than or equal to 10,000 or 100,000, excuse me. And then for here, we just do a simple if statement if it's not valid. So if this right here, if this value isn't right, display a message box. Please enter a valid number between 0 and 100,000. Invalid input has an OK button, and then it clears the text input. So that way the user can enter in something correct. I also have there's a cool thing in this right here. The max length is nice because it specifies, like it says here, the maximum number of characters that can be entered into this edit control. And since we know that 100,000 is the most that we want, we don't want to allow more than 6 digits. So that kind of does another set of restrictions on the operation itself. So if it's not valid, we do that. If it is, so everything else, it is valid, it satisfies the requirements. Then we make a stopwatch, start it. We create the integer array. It's empty right now, but it's of the same size as the value that was output from this. So even though this right here, it looks like it's like part of the inner workings of all this comparison, this is actually outputting a variable right here. This is outputting an integer variable named value containing whatever was in the input so long as it is an integer. It only will store it if it's an integer. So we have that here, and we use that to decide how big it is. My random instantiation, actually, you know what I'm going to do? I'm going to move that right now, right here, live, making adjustments to my code, because I don't care about testing how long that takes. Might as well just, it's probably pretty quick anyway, but anyway, keep it outside of the performance scope here. But yeah, I always name my random object Randy, and then just populate it up to the length, and I use numbers between 0 and 10,000, just in case somebody does wants an array of 500 numbers, then we know we have enough to populate it. But if it's an array over 10,000, so it's like 50,000, then there might be some repeats, but that doesn't mean it can't be sorted. And then we stop the stopwatch, save the time that was elapsed in milliseconds as a double, and then change the text color of the label to black from the soft gray that it starts out as, just to kind of show you like, hey, this is kind of where this goes. It's like a ghost text. And then insert the text time to make the array, and then insert the build time in milliseconds. And then for sorting, we do the same thing. We just use the built-in sort function, and then do the exact same thing. And then the progress bar is just based on if the build time is longer than sort time, which should be very rare. If you're building an array that's, I don't know, we could probably test it right on here, but If you're building an array that's small enough, then it might be, but most of the time the sort's going to take longer. But either way, I set whatever one's longer to 100, so you max that progress bar out. I do the same thing down here. And then whichever the other one is, I just get a percentage value by casting as an integer the sort time divided by the build time times 100. So that gives me, and that'll truncate the value down to a single integer. And then I just insert that as the value for the progress bar sort time or the progress bar build time, whichever one it is. So that way it fills it up to a certain amount. So let's see it in action. All right, here it is, running. So I'll show you first. I could do poo-poo, and it won't let me go past 6 characters. If I do put the old Python object-oriented programming in there, please enter a valid number between 0 and 100,000, clears it out. So let's do 50,000. As you can see here, it's got the time to make the array. Oh, I could slide those over too. It's kind of creeping in on it. But the time to make the array comes up, the time to sort the array comes up, and then you can tell a ratio. So this took, 3 whole seconds. This took way less. So it kind of gives you a ratio. And you can change it over to, 200 and run it again. You can change it to 10 and run it again. And this time making the array took longer than sorting it. So it's a small number. You can tell it changes it back and forth. I'm going to move these right now because that bothered me.